Today we are going to see about FCFS and SJF scheduling in operating system. Before going into the content, I would like to present myself. I am Mrs.E.Ponmalar, Associate Professor of Computer Science, the Standard Fireworks Rajaratnam College for Women, Sivagasi. We know what is meant by operating system. Operating system is a software which lies between the computer system and the users. Under the operating system subject, we have CPU scheduling. Our overview is, first we will be saying what CPU scheduler does and then scheduling criteria, followed by FCFS scheduling algorithm and SGF scheduling algorithm, within which we will see preemptive and non-preemptive scheduling. Considering CPU scheduler, we need to know what a CPU scheduler does. First we will see about what is a process. Process is a program in execution, and when a process enters into the main memory, it has to be executed, and when a process is there in the ready queue, we can allot the CPU and execute the process. We can have more than one process in the main memory at the same time. Hence, each process has to be loaded into the system and allocate the CPU, and the CPU has to execute the process. And each process has two time slots. One is CPU burst followed by IO burst. The CPU scheduler's job is thus to select one of the processes in the ready queue and allot the CPU for execution. The scheduling criteria is the second section we are going to see today. We have the 5 factors which act as the criteria for fixing the scheduling algorithm. What are those criteria? Number 1, CPU utilization, which is using the CPU maximum amount of time we have to use. So, if the CPU is idle 10% of the time, then we will say that the CPU utilization is 90%. And throughput. Throughput is the number of processes that you are going to execute within a per unit of time, and this has to be maximum. Turnaround time. We will submit a job and the job will enter into the computer as a process, execute, and the final answer will be over. This result is called as turnaround time, and the waiting time is from the beginning of submission of the process till the completion of the process. In between, the CPU may not be available for the process, and at that time the process has to wait in the ready queue, and that is called as waiting time of the process. And response time. Response time is calculated by the instant by which we are going to submit a process and the first reply that we are going to have from the CPU, that is called as response time. And we need, in the scheduling criteria, when we compare all the algorithms, CPU utilization must be maximum, throughput must be maximum, turnaround time must be minimum, waiting time must be minimum, response time must be minimum for each and every process. And we will see among the various algorithms available for CPU scheduling, the FCFS scheduling and SJF scheduling today. FCFS stands for first come, first served. And this algorithm is very simple to implement and understand, and we can implement it using a single FIFO ready queue, which stands for first in, first out. And in FCFS scheduling, we do not have any preemption. What is preemption? When a process is executing and forcefully we are going to take away that process and bring in the next process, that is called as preemption. And in FCFS, we do not have any preemption, whereas in SJF, we will be having preemption and non-preemption scheduling. And this FCFS scheduling algorithm is not suitable for time sharing systems, and the average waiting time is dependent on the order of processes that enter into the system. When we consider as an example, we have 3 processes P1, P2, P3, which have the CPU burst time 24, 3 and 3 respectively. And if the arriving order of the processes are P1, P2 and P3, the processes, first process is P1, so it starts at time 0 and it completes at the CPU burst time using 24 milliseconds for example. So, at time t equal to 24, P1 will be over and next comes P2. So, P2 will enter into the CPU and it will be allocated and execution will be over at time t equal to 24 plus 3 which is 27. And P3 will take again 3 units of time. So, 27 plus 3 equal to 30 and at time t equal to 30 all the 3 processes will complete their processes execution and hence now the waiting time we calculate P1 is not having any waiting time because at time t equal to 0 it enters. So, it is allocated the CPU at that time itself and for P2, P2 is waiting for 24 time units. So, the waiting time is 24 for P2 and P3 to enter into the CPU, the time interval it spends in the ready queue is 27 units. So, making the waiting time for P3 as 27 and after 3 milliseconds or time units it completes the job at 30. So, the average waiting time is 0 plus 24 plus 27 whole thing divided by number of processes which is equal to 3 making the average waiting time as 17 time units. And suppose the order is like this, P2 first comes in and then P3 and then P1, the same CPU burst time is considered. P2 will enter the CPU first. So, using the time interval of 3 time units the CPU burst. So, it will complete at time t equal to 3 and P3 enters next, executes the CPU in the CPU and the execution is complete at t equal to 6 and next followed by P1 and it executes starting at 6 completes at 30 and the average waiting time is calculated as such. For P2 it is having no waiting time. So, 0 for P1 the waiting time is 3 and then P3 it is 3 and P1 it is 6 milliseconds or time units. So, totally the average waiting time is 9 by 3 which is 3 units of time. And now, we have the drawbacks or disadvantages of FCFS namely convoy effect and non-preemptive. What is convoy effect? We have short processes which come later. So, what happens is long processes to complete the CPU will not be allocated for those long processes and they will be waiting in the ready queue for more amount of time. In our example itself, when the order was P1, P2, P3, the waiting time was more, whereas for the second one that is P2, P3, P1 where P1 is a long process. So, we are having the waiting time total average it is only 3. So, short processes if they are going to wait then the time taken will be more and long processes when we postpone it executes more short process will be executed and the waiting time will be less. Thereby it is a disadvantage or a drawback of FCFS. The second drawback is non-preemptiveness. FCFS is non-preemptive hence we cannot or it is not suitable for time sharing systems. And now coming to SJF. SJF stands for shortest job first scheduling. So, here what we do, we have the two schemes non-preemptive SJF or preemptive SJF. Non-preemptive SJF, we are going to order the processes in the order of the time, CPU burst time. So, the CPU will be allocated to the process with the CPU burst time which is smallest first time and then followed by the next CPU burst slightly larger and so on, and if the CPU burst is the maximum it will be coming at the last. And when we have two processes with the same CPU burst we can arbitrarily break the time. And in SJF shortest job first scheduling, if it is non-preemptive we call it as directly as SJF and if it is following preemptive scheduling where the processes which are currently in execution we are going to forcefully take it away and allocate the CPU for the next shortest job, then it is called as preemptive and this scheduling we call it as shortest remaining time first scheduling. So, we will see first non-preemptive SJF scheduling. Here we have 4 processes and the arrival time is 0, 2, 4, 5 respectively for P1, P2, P3, P4 and the CPU burst time is 7, 4, 1, 4. So, initially at time t equal to 0, P1 enters the queue and it is starting execution, CPU is allocated, and when time t equal to 2, P2 enters with the CPU burst request of 4 units of time, and the remaining time needed for P1 will be 7 minus 2 because t equal to 2, and hence the CPU remaining time is actually 5, and we have P3 with requirement 1 and it comes at 4. Now, at time t equal to 2, P2 is entering with 4 CPU burst and the remaining time in P1 is 5, but because it is non-preemptive, we permit P1 to complete. So, at time t equal to 7, P1 will complete, and when time equal to 7, we have P2, P3, P4 all in the queue with the minimum CPU burst time for P3 as 1 and P2 and P4 with the same CPU burst. So, we can arbitrarily break the tie taking P2 first. So, P1 completes at time t equal to 7 and P2 enters and the CPU burst is 4. So, at 7 plus 4, 11, P3 will complete, and then P2 will be P3 will be executing with shortest time 1. So, 7 plus 1, 8. So, at time t equal to 8, P3 will complete, and we have P2 and P4 with 4 time intervals. So, 8 plus 4, 12 will complete P2, and again at time t equal to 12, P4 will begin execution, and at time t equal to 16, P4 will complete. So, P1 completes first, and out of the remaining 3, P3 is having the shortest time as 1. So, P3 will be executing the in the CPU next, followed by P2, followed by P4. Now, the average waiting time is for P1 it is 0 and P2 it is 8, P3 it is 4 and for P4 it is 12. So, the average waiting time is 6.75. Now, preemptive SJF. The same thing what we have seen in SJF is to be followed for SRTF, shortest remaining time first scheduling. Here only difference is at time t equal to 2, P2 is entering with the request of 4 units of time, whereas P1 has completed only 2 unit of time. So, remaining 5 CPU burst is required for the P1 process. So, 5 and 4 when we compare at time t equal to 2, 4 is less than 5. So, P1 is forcefully taken away from the CPU and the CPU is now allocated to P2. So, after P1 completes for 2 milliseconds, we will allocate P2. And P2 will start execution at time t equal to 2 and P3 at time t equal to 4 will enter, and now the balance time in P1 is 5, P2 is 2 and P3 now it requires only 1 CPU burst. So, 5, 2, 1, P3 is having now the request with 1 unit of time or milliseconds which is less than 2 and 5. So, now P3 will be executing. So, P3 will arrive and P3 will be executed and it gets the CPU, and after P3 gets completed, now we will have P1 with 5 CPU burst required, P2 with 2 and P4 with 4. Out of 5, 2 and 4, 2 is the minimum. So, P2 will be allocated the 2 CPU burst times and P2 will execute in the CPU. And then remaining 5 for P1 and P4 we have only 4 CPU bursts. So, P4 actually will complete 4 units of time, then followed by 5 unit of time by the P1 process. Thus, the preemptive SJF is actually termed as SRTF because it considers the shortest remaining time first algorithm, and hence now the average waiting time is 9 plus 1 plus 0 plus 2 divided by number of processes 4 and the average waiting time is 3. So, in the today's session we have seen first the process scheduling, CPU scheduling list of algorithms, where we have selected only 2 algorithms, FCFS scheduling algorithm and SJF scheduling algorithm. within SJF we have completed the two types, namely preemptive SJF scheduling, which is also called as SRTF scheduling or shortest remaining time first algorithm, and non-preemptive scheduling algorithm. Non-preemptive is nothing but shortest job first algorithm. Thank you for listening, and we'll meet the next time with the remaining two algorithms. Bye bye.